So in the next half an hour or 45 minutes or so, our objective that we'll try to achieve is basically the sum of the geometric sequence, which is geometric series. We'll be also working on the infinite sum, which is sum to infinity concept. And if time permits, we'll work on financial mathematics, loans, and annuities. So the first thing that comes to our mind is that what is exactly the formula to add up the first n terms of the geometric series. So let's say we have got a geometric series, let's say 2, 6, 18, and so on. Here, the ratio of the sequence that you see is 3. So if I want to add up 2 plus 6 plus 18 and so on, let's say first n terms of the sequence, first n terms. So when we add up the first n terms, the specific formula that we use in the DP is Sn, which is to show some of the first n terms, is given by u1 ratio to the power n minus 1 over r minus 1. So here ratio r is nothing but the ratio. So r is the ratio of the sequence. And n is the number of terms that we are adding. So number of terms being added. Now let us say if we have to add the first 5 terms or 7 terms of the sequence. Let's say I wanted to find out S10 for the sequence. So I can take my U1, that's the first term. So U1 will be nothing but 2 times ratio will be 3, because ratio you take always second term upon first term. So ratio is 3 to the power 10 minus 1 over 3 minus 1. So r minus 1, that's your ratio minus 1. So you can use technology to find out this value. And another interesting thing is that you can manipulate this formula a little bit to get the second formula. So if I can take just, let's say, Sn formula for us is u1 r to the power n minus 1 over r minus 1. This can be also written as minus, u1, if I take minus common from the numerator, I'll get 1 minus r to the power n over 1 minus r. So this, and if I take minus common from the denominator as well. So if I take minus common, so this minus and minus get cancelled. So you get u1, 1 minus r to the power n over 1 minus r. So this is the formula for the geometric sequence. The series, some of the first n terms. So you can use any of the formula like this one or this one. Both will give you at the end the same correct answer. So here the second term of the sequence, like this is a particular question where second term of the sequence has been given as 6 and the sum of the first 3 terms has been given as negative 14, and we are asked to calculate the first term and the ratio. So now let us say if you have second term is 6. So what we do is we use the formula like second term. If I take first term as u1, second term will be u1r, and third term will be u1r squared. So when you want to find out the, let's say, the first equation according to the given data, the second term is 6. So u1 times r is 6, and then they have given that S3 is negative 14. So you will do u1 plus u1r plus u1r square is equals to negative 14. So out of the given data that we have, u1r is 6. So this point, this value is 6. So you can do one thing is u1 plus u1r squared plus 6 equals to negative 14. And then from here, what we get is u1 plus u1r squared is negative 20. And then also we'll make use of this particular stuff. u1r is 6. So what we can do is we can say now we have two equations. u1r is 6 and u1 plus u1r square is negative 20. So after this step, we make u1 the subject of the formula. So u1 will be 6 over r, which is this. And if you take u1 common from here, you'll get minus 20 over 1 plus r squared. So if you equate both of them, you get a quadratic. You solve that quadratic, you get two values of r. Once you get the value of r, you plug those r values here to get the value of u1. You can do in any of the equation, like either in this equation or in this equation. That should be all right. So that's how you do this particular question on the series of the geometric sequence. So sigma notation is sigma is one of the ways to represent basically the sum. So sigma notation is one of the important and like alternative way to write down the sum, or giving like a command to write down the sum of a particular sequence. So let's say if I have got this notation somewhere like a, a flipped kind of e, you can see that this is sigma notation. Now this simply means sum. Now, if it is telling us to do sum, now sum of what? Like, so here you'll be generally given a particular sequence. So the sequence for which you have to find out the sum, you'll be given out here. And also you'll be given certain starting point. Here you'll be starting point, starting, and here will be the ending point. It's always given on the particular like a sigma notation itself. So let's say if I have been given sigma r equals to 1 to 5, let's say 2r plus 1. So this, what does this mean to us? So this means is basically take r value as 1, 2, 3, 4, 5. Okay, so start from r equals to 1. So first term will be 2 times 1 plus 1, which is 3. Take r as 2. So it'll be 2 times 2 plus 1, which is 2 times 2 is 4. 4 plus 1 is basically 5. Similarly, take r as 3. So it'll be 2 times 3 plus 1, which is 7. And next will be, obviously, you can see the pattern already. So to 3, 5, 7, 9. And when you take r as 5, it will be 9, then 11, then 13. So basically what you have to do is you have to add up 3 plus 5 plus 7 plus 9 plus basically 11. So r equals to 1 to 5. So when I take r as 5, so 5 twos are, so it'll be 5 times 2, which is 10, 10 plus 1 is 11. So you have to basically add up the sum of the first 5 terms, which you obviously can add it up, you'll get a fixed number. So this is actually the command or a way to add up a particular like number of sequence, number of terms or given sequence. Now, for example, if I have, let's say, sigma n squared from n equals to 3 to, let's say, 8. Now, what does this mean to us? This simply means that you take n as 3 squared, 4 squared, 5 squared, 6 squared, 7 squared until 8 squared. So this is how you add up the how to make use of sigma notation and like decode backwards. Let me give one more example for this. Is basically, let's say if I have got 3, 5, 7, 9, and so on. So this is the sequence that we have got, and they asked us to write down, show the first n terms of this sequence in form of sigma notation. So here, like, you have been given expanded form and you have to write down the sigma notation. So generally what happens is that if you have the first few terms, you can use the formulas that are there. So nth term formula here will be, so nth term will be uh, uh, 3 plus n minus 1 times difference, which is 2. So 3 plus 2n minus 2, which is 2n plus 1. So this is the formula for the um, nth term formula for that sequence. Now, when you're writing the sum, let's say they say write down sum of first 100 terms. Now, sum of the first 100 term, if they say, will be written as sigma 2n plus 1. You can take 2r plus 1 also, it's okay to take r equals to 1 to r equals to 100. So sum of first 100 terms they say. So r equals to 1 to 100. That's how you um, work backwards. And of course, sometimes they'll say that, okay, evaluate this. Now, in that case, you already have the formula. So some of the arithmetic sequence, arithmetic series formula is SNS n over 2, 2u1 plus n minus 1 times difference. So if I had to evaluate this, what I'm going to do is I'm just going to write down 100 over 2. Then you will have 2 times u1, which is nothing but 3 plus n minus 1, so which is 99 times difference, which is 2. So evaluation you will do using the formulas that are there, but sigma is just an alternate way or alternate style to write down a particular sum in more concise and condensed way. So that's how you tackle the sum formula or the sum command for the particular sequence. So as per the key concept, we have this as one of the last fragment on the sequences part, which is infinite sum. Now, why we call it as infinite sum? Let's say first figure out a couple of reasons and the methods for it. So let us say there are two types of sequences. I'm writing is, let's say, 2, 4, and let's say this is 8 and then 16 and so on. And the other one is something like 16, 8, 4, 2, 1, half, and so on. So as the word infinite, firstly, what is the source of the word infinite? Now, infinite basically means that you're adding up infinite number of terms. What if we have to add up a billion terms of a particular sequence? Now, if you look at simply this particular question, like here, the fourth term itself is 16. Now, when I find out the, let's say, probably the, let's say, thousandth term, let's say I want to find out u thousand, which will be 2 times 2 to the power, let's say, 999, because that's what is the formula. And also you can look at the pattern is also very clear. So it'll be 2 to the power 1000. Now, when you want to find out 2 to the power 1000 value, it will be huge value. And this is, we're still at thousandth term, which is still countable. But if I want to find out, let's say, billionth term, it'll be huge number, which you can't have, like, which we can't like even write down properly. So what happened is that we add up the particular sequence uh, and try to see if that number comes to a finite answer. So the first one will be definitely going to infinity. If you simply look at the graphical way, the 2 raised to n graph is something like this. So as n becomes larger, the 2 raised to n, the value of the term itself goes towards infinity. You can see this. So the logically, this particular sequence is referred as a diverging sequence. And you cannot add infinite term of the sequence. So diverging sequences are the ones which are excluded from being added as an infinite term. Now look at the next sequence. Let us say 16, 8, 4, 2, 1, half. Now just imagine the fifth or sixth term itself has become half. Now further as you go, as you continue writing, the next term will be 1/4, next will be 1/4, further half, which is 1/8, and so on. So the maybe if you find out the 20th or 100th term itself will be like very close to zero. And even though you take billion or gazillion terms, it doesn't make a difference, because at the end of the day, rest of the terms are becoming close to zero after a particular decimal places. So they are not going to make any significant difference in the values of the sum that we're getting. So like, for example, if I have, let's say, if I keep writing, maybe after we do the 50th term will be something like this, 0.0000, something like that, very small number. So this will be like almost negligible. So that's where, in this case, we can add up these terms. We can add up the particular sequence terms. And this is referred as the sum to infinity. Now, what happened actually is that there is a genuine reason to it. So let's say if you got Sn, it will be u1, 1 minus r to the power n over 1 minus r. So Sn is u1, 1 minus r to the power n over 1 minus r. Now, if ratio is between -1 and 1 for any particular sequence, this is called as a converging sequence. So if ratios between -1 and 1, what happen is that r to the power n becomes 0 when n tends to infinity. So if n is really large number, r to the power infinity becomes 0. R to the power infinity becomes 0 because like half an apple you're dividing in infinite parts. Each part corresponds to 0. So this formula basically S infinity, when you write down, actually is u1 over 1 minus r. So this part becomes almost 0, and that's where the sum to infinity comes in picture. And your S infinity formula is u1 upon 1 minus r, and this is the maximum sum that this particular sequence can achieve. So let us say if I have to find out S infinity for this second sequence, which 16 is my first term, upon 1 minus half, ratio is half for this sequence. So that's where you get 16 upon half, which is nothing but 32. So if S infinity is 32, it means that the maximum sum, even I keep adding all the terms of the series, it will never ever cross above 32. And that's where this kind of sequences are called as converging sequence. Well, some converge to a fixed number. And graphically, if I have to show you, graphically it is like this. So if it is n, and here it is some value, so it is going to become stagnant like this. Irrespective of the number of terms that you increase, it will not make any difference in the sum that you're getting. And this is referred as the sum to infinity. So let us take some more problems on this to understand the origin and the logic of this particular formula better. So when you're finding out, let's say, sum to infinity in this case, first you just write down the first few terms. Uh, See here, this infinity itself is an indicator that you have to find out the sum of the infinite terms. So you plug in k as 1, k as 2, k as 3, get the first few terms. Then you find out u1. u1 is 3/4 and the ratio is 1/4. Plug in the formula. S infinity is u1 over 1 minus r, and you get the value of the sum. And similarly for the second one, when you take k as 0 to infinity, here I don't start with k as 1. You have to be careful that you're starting from 0. So plug k as 0, k as 1, k as 2, and so on. And you get the sum. U1 is 6 and ratio is negative 2/5 because it's every alternate plus, minus, plus. So ratio is negative 2/5. And just plug in the formula to get the sum to infinity.